Hello and welcome you all. Dear students, today's topic is operations on DT, that is discrete time signals, part 1. This is the topic from the subject signals and systems for second year ENTC students. We will be discussing the operations of DT signal. Same analogy is applicable for continuous time signal. Before that, we should know how to plot the graph. Suppose given sequence is x of n is equals to 1 minus 1 to 1. As an example, I have randomly considered any sequence. In the given sequence, always some arrow will be marked. Suppose arrow is at minus 1. Now, how to draw the diagram of this signal? We know that if it is a DT signal, that is discrete time signal, it is graph of x of n versus n. N is known as index, which represents corresponding number of a sample, and value of n must be integer. There should not be any decimal point. Arrow always indicates the value at n is equals to 0. Do remember, these given values are values of amplitudes of the signal. So start reading every signal from left to right. So if I will read the amplitudes from left to right, it is 1 minus 1 to 1. So given things are amplitudes of the signal x of n. Value of n will not be mentioned anywhere in the given sequence. How to identify it? Check the arrow. Wherever arrow is there, at that position value of n is 0. At the right hand side of arrow, this is value at n is equals to 1. For this sample, value of n is equals to 2. So at the right hand side, check the arrow. Wherever arrow is there, mark n is equals to 0. At the right hand side, mark n is equals to 1, n is equals to 2, up to n is equals to infinity. At the left hand side of arrow, this value is for n is equals to minus 1. So amplitudes were given. Given amplitudes are 1 minus 1 to 1. Value of n was not given in the sequence. Then I identified the arrow. At arrow, I marked n is equals to 0. At the right hand side, I marked 1, 2. At the left hand side, I have marked minus 1. So range of n, range means starting value of n is minus 1, ending value of n is 2. So on x-axis, that means on the axis where I have marked n, mark this scale. So this is origin, this is minus 1, this is 1, this is 2, because value of n is from minus 1 to 2. Don't get confused. These are amplitudes. Given things are amplitudes, these are not values of n. Value of n we have predicted, we have calculated. So it is from minus 1 to plus 2. Now at minus 1, amplitude is 1. So draw a pulse of amplitude 1. Then at 0, amplitude is minus 1. Since it is negative amplitude, I will mark the pulse like this. For every pulse, you need to write the magnitude. Then at n is equals to 2, magnitude or amplitude is 2. So I will mark the pulse of level 2. Then at n is equals to 2, amplitude is 1. So this is the way how to draw the diagram from the given sequence. Reverse way, suppose this sequence is not given. This is not given, only diagram is given. Then how to write the sequence from the given diagram? The given sequence is a discrete sequence, so it is x of n. In the sequence, always and always keep in mind, you don't have to write anywhere value of n. Just go on writing the amplitudes of signal from left to right. So read amplitudes only. So it is 1 minus 1 to 1. So as I said, simply go on writing the amplitude levels, that is 1 minus 1 to 1 to 1. Now at n is equals to 0, amplitude is minus 1. Whatever amplitude is there at n is equals to 0, it is minus 1. Mark arrow at minus 1. So this is the way how you can write, you can generate the sequence if diagram is given. Now first type of operation is time shifting operation. As an example, I will consider the sequence x of n is equals to 1, 2, 3. Arrow is at 1. One more thing, if arrow is not given in any sequence, by default consider it at first position. Presently arrow is given, it is 1, 2, 3. Let us draw the diagram for this given sequence. Just now I told you, wherever arrow is there, it represents value of n. So n is equals to 0. At the right hand side, I will mark this value at n is equals to 1, this value at n is equals to 2. So on this axis, that is on a horizontal axis, mark the reading 0, then n is equals to 1, n is equals to 2. Now at n is equals to 0, amplitude is 1. So I will mark the corresponding amplitude level. At n is equals to 0, I have amplitude 1. At n is equals to 1, amplitude is 2. So this amplitude is 2. At n is equals to 2, amplitude is 3. So this corresponding amplitude is 3. So I have marked the signal x of n. Now in case of time shifting operation, as the name indicates, there is shifting with respect to time, that means with respect to n. So first type of time shifting operation is a delay operation. Delay means, as the name indicates, it is the time delay. That means signals are getting late, signals are appearing late. The corresponding notation is x of n minus k. How to remember it? Whenever minus sign is there, it indicates a delay operation. This notation k indicates amount by which signal is delayed. Let us say I want to delay the signal by one amount, so I will use the notation x of n minus 1. It indicates, minus sign is there, so it indicates it is a delay operation, and value of k is 1, so it indicates signal is getting delayed, it will be late by one position. Now refer the original diagram. Keep in mind, always and always read the diagram, read the amplitude levels from left to right, never do it in other way. So starting amplitude is 1, so amplitude levels are 1, 2, 3, and starting position of this original diagram is at n is equals to 0. I want to delay this signal by one position, that means it will start late after one position. So new diagram corresponding to this will be, I will first mark the readings, I will mark the scale, so 0, 1, 2, 3 and so on. I want to delay this by one position, that means it will start later or after one position. So I got the starting point 1. Instead of 0, it will be starting from 1. Just identify the starting point. Amplitude levels are 1, 2, 3. Go on marking amplitude levels as it is. So it is 1, 2, 3, because I am not making any changes in the amplitude levels. This is known as a delayed signal. It is delayed by one position. Suppose I want to delay it by two positions, then the notation would have been x of n minus 2, and this diagram would have been started from 2. So you just have to identify the starting point. Now this is the diagram. If you want to write the sequence from this diagram, how to do it? What I said, if diagram is given and you want to write the sequence, then go on writing the amplitudes of signal from left to right. From left to right means at 0 there is no signal, that means amplitude is 0. Next amplitude is 1, 2, 3. What's the rule? Whatever amplitude you have at n is equals to 0, mark an arrow. So arrow will be like this. Now don't get confused. If you compare these two sequences, this sequence and this sequence, you will come to know that arrow is shifted towards left. Compared to this, arrow is shifted towards left, but diagram is shifted towards right. To avoid the confusion, just think about the diagram. So how to remember? I will make a summary over here. If x of n is the sequence, I will write it over here. If x of n is the sequence, then its delay is denoted by x of n minus k, and remember it like this. Delay means shift right. SR means shift right. So you have to shift the diagram towards right by corresponding position. The second operation related to this is advanced operation. It is opposite to that of delay operation. In case of delay, what I said, signals are getting late. Signals will start after some time. In advance, it is reverse operation. Signals will start early. Suppose I will write the notation x of n plus k. Plus sign indicates it is advanced operation. K indicates amount like this. K indicates amount by which signal is advanced. If I want to advance this signal by one position, I will write here x of n plus 1. Make the thing simple. Since I want to advance this original signal, this part is over. I am talking about original signal, given signal. If I want to advance this given signal by one position, it should start earlier. Earlier by how much amount? By one amount. the original signal was starting from n is equals to 0. So next starting value will be at n is equals to -1. Again mark the readings. Remember the rule. Amplitude levels will be as it is. What are amplitude levels? 1, 2, 3. You just have to identify the starting point. So starting point is, since it is advanced, it will start earlier by one position. Original signal was starting from 0. So it is starting earlier by one position. So new signal will start from 1 and amplitude levels will be as it is, that is 1, 2 and 3. That's it. You don't have to think about amplitude levels. Just identify the starting point and mark the amplitudes. Now, from this diagram, I want to write the sequence. Rule is same. Read the amplitude levels. Read the amplitude levels from left to right. Amplitude levels are 1, 2, 3. Whatever amplitude you have at n is equals to 0, mark an arrow. So I will mark an arrow over here. So this is known as the advanced operation. How to remember it? If for sequence x of n, delay is x of n minus k, opposite case, advance is denoted by x of n plus k, and advance means shift diagram towards left. Now, the third operation, it is folding operation. This is most important operation. Folding is also called as mirror image. We know that in case of a mirror image, the left side and right hand side are interchanged. Now mathematically, this folding of given sequence x of n is denoted by x of minus n. Do remember this notation? Folding of given sequence x of n is denoted by x of minus n. In the earlier cases, what I said, in case of delay, shift diagram towards right. In case of advance, shift diagram towards left. First draw the diagram and then from the diagram write the sequence. Only in case of folding operation, just to avoid the confusion, first write the sequence in reverse way, reverse order. This was the original sequence. 1, 2, 3, arrow was at position 1, arrow was at value 1. Now write the sequence in reverse order. Reverse order means it is 3, 2, 1. Why do write in reverse order? Because as I said, it is a mirror image, and in case of mirror image, left hand side and right hand sides are interchanged. So I will write the given sequence in reverse order. Sequence was 1, 2, 3. I have written it as 3, 2, 1. But keep arrow as it is. Arrow was at 1, so I will mark arrow at 1 itself. Don't change the value at which arrow was marked. Value was 1 at which arrow was originally marked. So wherever 1 is there, I will mark an arrow. Now this is the folding operation. This is the folded signal. How to draw the diagram for this folded signal? Same logic. This is the arrow. We know that wherever arrow is there, I have to mark n is equals to 0. At the left hand side of arrow, this is n is equals to -1. This value is at n is equals to -2. This is n is equals to -1. So mark the scale. This is n is equals to 0. This is n is equals to -1. This is n is equals to -2. Now, at n is equals to 0, amplitude is 1. So at 0, I will mark the pulse of amplitude 1. At -1, this is value n is equals to -1. At -1, amplitude is 2. I will mark the pulse of amplitude 2. At -2, n is equals to 3. Amplitude is 3, so I will mark the pulse of amplitude 3. This is the folded sequence x of n. Observe these two diagrams. In case of folding, it is just a mirror image. The entire diagram earlier, originally, was at right hand side. Now it becomes at left hand side. This is the folding operation. But keep in mind, only in case of folding, first step is write the sequence in reverse order. Keep arrow as it is wherever it was there originally, and then from the sequence draw the diagram. Now before starting the next operations, we will make a summary just to avoid the confusion. So I have written the notations for sequence x of n. Now if you want to write the notations for sequence x of minus n, we discussed that x of minus n indicates a folding operation. How to generate the sequence for its delayed operation. Now, delay of x of n is x of n minus k. I will tell you the simple trick. Folding is mirror image. How this sequence, how this notation was generated, it was x of n. I wrote it as x of minus n. Simple way. Just remember this notation. delay of x of n was denoted by x of n minus k. I want to write the notation, generate the notation for delay of x of minus n. Change the signs of each variable. It is actually n minus k. That means plus n minus k. I will write it as minus n plus k. Basic meaning remains same. That is shift right. So you just have to shift the diagram towards right. Same way, I want to generate notation for advance of folding operation. This first operation is delay of folding operation. Second is advance of folding operation. Same logic. If you know this notation, change the signs of each variable. It is x of plus n plus k. So new notation will be x of minus n minus k. Very simple. It was plus n plus k. I have changed the signs. It become minus n minus k. But stick to the basics. Advance is shift left. So this is advance. So it is again shift left. Once you will remember all these things, then any operation is pretty simple, damn easy. So you just have to remember this. Now let us discuss the fourth operation, that is delay of folding. Suppose I want to delay this folded signal. I am referring this folded signal, not this original diagram. I want to delay this folded sequence by one position. I have made a list of notations. So delay by k is x of minus n plus k. I want to delay the folding operation, delay the folding sequence by one position. So corresponding notation will be x of minus n plus 1. Why? Because notation is x of minus n plus k. In place of k, I have put value 1. Stick to the basics. This is the notation which I have generated from this. Now delay means always shift diagram towards right. By how many positions? By one position. So this diagram of folded signal, I have to shift it towards right by one position. Think like this. Every diagram starts from left hand side. So starting point of this diagram is at minus 2. I have to shift it towards right by one position. So starting point will be shifted towards right by one position. So starting point will be minus 1. So new diagram will start from minus 1. First let me mark the reading. This is minus 1, 0, 1 and so on. Amplitude levels as usual in all diagrams will be as it is. Amplitude levels are 3, 2, 1. So I will go on marking the amplitude level. This is 3, next is 2, next is 1. That's it. What I did, generated the notation from this. I want to delay this folded sequence by one position. So I wrote the notation. This was starting from minus 2. I have shifted this diagram towards right by one position. I have got this diagram. Now from the diagram, write the sequence. We know the rule how to write the sequence from this diagram. Read the amplitudes from left to right. So amplitudes are 3, 2, 1. From left to right always. Amplitude at n is equals to 0 is 2. Whatever amplitude at n is equals to 0 is there, mark an arrow. So this is the sequence which I have written from the diagram. Now last operation related to this time shifting operations is advance of folding operation. Advance of folding. Same way, first I need to write the notation. Look at the notation which I have summarized. Advance is denoted by x of minus n minus k. I want to advance this folded sequence by one position. So corresponding notation will be x of minus n minus 1. But stick to the basics. Advance means shift left. So I have to shift this diagram, folded diagram, towards left by one position. This diagram, I will draw it over here. This diagram, original diagram was starting from minus 2. New diagram will be shifted towards left by one position. So first let me mark the reading 0, minus 1, minus 2, minus 3. So starting point was at minus 2. It will be shifted towards left by one position. So starting point will be at minus 3 and levels will be same, that is 3, 2, 1. So it is 3, then 2, then 1 and nothing is there. If nothing is there, you can mark 0. Now from this diagram, if I want to write the sequence, how to do it? Read the amplitude levels from left to right. It is 3, 2, 1 and 0, because at 0 nothing is there, but you need to mark arrow at 0, so I will mark an arrow. So this is the way how you can draw or how you can perform the time shifting operations. Now, dear students, if you are still finding it confusing, I will tell you the simplest trick. Remember it like this. Forget about the names, delay, advance and folding and so on. Just check the signs. If inside the bracket, if you see opposite sign means plus minus like this or minus plus like this, shift diagram towards right. Make it more simple. Names are immaterial. So just check the signs inside the bracket. Opposite sign means shift right. This is minus plus, opposite sign shift right. If in the bracket same sign is there, shift diagram towards left. Very simple. Look at this first case. It is inside the bracket, sign is plus minus, opposite sign shift right. Sign is plus n plus k. Actually it is n plus k, means plus n plus k. Same sign, shift left. Then this is minus plus, opposite sign shift right. Minus minus, same sign, shift left. So if you simply remember this rule, opposite sign is shift right, same sign is shift left, you can perform any operation related to time shifting. Now let us discuss the remaining operations. The next operation is time scaling operations. As the name indicates, here time is scaled, that means time is changed. For the simplicity, I am considering same sequence x of n is 1, 2, 3 diagram, which we have already discussed. This is the diagram of given sequence x of n. Suppose I want to perform the operation x of 2n. X of 2n. Now, how to do it? Just for the simplicity, from the given diagram, I will write the values like this. X of 0 is equals to 1. How I wrote this value? Because value of x of n at n is equals to 0 is 1. So I have written it as x of 0 is equals to 1. Next, at n is equals to 1, value of x of n is 2. It is expressed like this. X of 1 is equals to 2. X of 1 means value of x of n at 1, it is 2. Same way, x of 2 is equals to 3, because at 2 value is 3, so x of 2 is 3. Now we want to perform this operation x of 2n. Let us put some values. So how to put the values? This given sequence starts from n is equals to 0. We know that this is n is equals to 1. This is n is equals to 2. So this value is for n is equals to 1 and so on. Now this sequence is starting from 0. So I will start doing the calculations from 0. So in this equation, put first value for n is equals to 0. Given equation is x of 2n. For this n, I want to put n is equals to 0. So 0 into 2, it becomes x of 0. This is the set which we are using as a reference. X of 0 is equals to 1. So value of this is equals to 1. Same way, go on incrementing the values. So next n is equals to 1. In this given equation, whenever n is there, put n is equals to 1. So you will get the equation x of 2, because I am putting n is equals to 1. 1 into 2 becomes 2. So it is x of 2. Value of x of 2 is equals to 3. So this value is 3. Now this is the last value. If you go on incrementing the values again, you will be getting zeros, because this 3 is the last value that we have achieved. So stop doing the calculations at this end. Now from this, I have to draw the diagram. How to draw the diagram? At n is equals to 0, amplitude is 1. So new diagram will be like this. I will mark the scale, n is equals to 0, n is equals to 1, 2, 3 and so on. At n is equals to 0, amplitude is 1. So at n is equals to 0, I will mark the pulse of amplitude 1. At n is equals to 1, amplitude is 3. At n is equals to 1, I will mark the pulse of amplitude 3. That's it. This is the diagram for x of 2n. Now observe these two diagrams, given diagram and this diagram. Quite clearly we can say that one sample is deleted because number of samples are reduced, so time is compressed. This type of operation is known as downscaling. Why downscaling? Because originally signal was broad, it is reduced by deleting some samples. So this operation is known as downscaling operation. Same way, suppose I want to perform the new operation. Let us say I want to perform x of n by 2. Now, how to do it? Like the previous case, the starting value is n is equals to 0. So first I will put n is equals to 0 in this given equation. Equation is n by 2. So it becomes x of 0 by 2. 0 by 2 is 0. So it gives me x of 0. Value of x of 0 is 1. See, whenever you are getting this equation, put the values from the given set. So x of 0 is equals to 1. Go on incrementing the values. Next is n is equals to 1. This gives me x of 1 by 2. Because I am putting n is equals to 1. X of 1 by 2. There is no value of x of 1 by 2 in the set. Whenever there is no value, mark it as 0. Next value, n is equals to 2. You will get x of 2 by 2. From this equation, I am putting n is equals to 2. X of 2 by 2 means it is same as x of 1. Check the value in the set, it is equals to 2. So I will mark this value as 2. Again, put next value n is equals to 3. You will get x of 3 by 2. I am putting n is equals to 3 over here. X of 3 by 2. There is no value of x of 3 by 2. Whenever you don't have any values, mark it as 0. Next, n is equals to 4. You will get x of 4 by 2. I am putting n is equals to 4. X of 4 by 2 is same as x of 2. X of 2 is this value 3. This is the ending value because we have values up to 3 only. So now I have got this chart, this new calculations. How to plot the diagram? Again, same logic. Mark some readings like this. So it is 0, 1, 2, 3, 4, 5 and so on. You just have to mark the diagrams like this. At 0, amplitude is 1. At 1, amplitude is 0 and so on. So at 0, amplitude is 1, mark a pulse of amplitude 1. At 1, amplitude is 0, mark 0. At 2, amplitude is 2, mark a pulse of 2. At 3, amplitude is 0, mark a pulse of 0. At 4, amplitude is 3, so mark 3. And so on. This is the ending calculation. So if you compare this diagram with the original diagram, that is diagram of x of n, you can well observe there is expansion of the given diagram. So this type of operation is known as upscaling operation. Upscaling operation. So these types of operations in which we have changed the time periods of a signal, these operations are known as time scaling operations. Now the remaining operation, a pretty simple part, is amplitude scaling operation. As the name indicates, amplitude of the signal is scaled. Scaling means changing. Suppose this is the given sequence. I want to perform 2 into x of n. Remember, earlier case was x of 2n. Now what I am writing, 2 into x of n means every amplitude is to be multiplied by 2. So directly from the given sequence you can write levels are 2, 4, 6. Keep arrow as it is. Diagram, again diagram remains same, only amplitudes will be different. So this is 2, 4, 6. That's it. This is known as amplitude scaling operation. Suppose I want to perform 1/2 x of n. Same way, every amplitude will be divided by 2. So first amplitude is 1 by 2, that is 0.5. Do remember, amplitude can be anything, but value of n should be integer. This is amplitude, so 0.5 is allowed. Next 2 by 2, that is 1. Next 3 by 2, that is 1.5, or you can even write 3 by 2. So arrow remains as it is. So new amplitudes are 0.5, 1 and 1.5. That's it. So in the diagram you can well show these values. It is 0.5, 1 and 1.5. So this is known as amplitude scaling operation. So dear students, this was the part 1 of operations on DT signals, that is discrete signals. In the next part we will solve corresponding numericals related to this part. So thank you. Thanks a lot.